Let's look at inverse matrices. This will get us to a point where we'll be able to solve systems of equations using matrices. But first, let's identify an inverse matrix and get some definitions. Before we can look at the inverse, we need to know the definition of an identity matrix. An identity matrix is noted as an I sub n. N represents the size. It's always a square matrix, n by n matrix, for which each main diagonal entry is 1 and all other entries are 0. So I sub 2 means it's a 2 by 2 matrix with 1s along the main diagonal. This is what we mean by main diagonal, and 0s everywhere else. I3 is a 3 by 3 matrix with 1s along the main diagonal, 0s everywhere else. I4 is going to be a 4 by 4 matrix with 1s along the main diagonal, and 0s everywhere else. So that would be I4, the identity matrix of order 4. Tells you the size. For any matrix, remember we saw this I3 earlier when we multiplied F times B. For any square matrix A times I sub n is going to be equal to itself A. Or I could say the identity matrix times A is going to be equal to A. It's just like the element 1 when we're dealing with arithmetic. 2 times 1 is equal to 2. 1 is the identity element in multiplication when you're dealing with just real numbers. Well, I can't use the number 1 over here, so the matrix I sub n, the identity matrix, acts just like the number 1 over here. It's the identity element in matrix multiplication. So any matrix times the identity is itself. Or the identity times the matrix will always be the original matrix. So here's matrix A. We don't need to literally show that A times I is equal to A because we did it earlier when we did F times B. But if you wanted to take the time and show it, we can multiply A times its identity. It would have to be it'd have to be order 3 by 3 matrix. And if I multiplied row by column, I would get matrix A. Actually, you could get some practice, put it in your calculator, and show that A times I is equal to A. Now, that's needed for the definition of a matrix. Of an inverse matrix. It says let A be a square matrix. So we can only work with a square matrix when we're finding the inverse. If there exists another square matrix, we're going to call it A minus 1 for an inverse. If there exists an A minus 1 such that matrix A times this inverse is the same answer as the inverse times A, which is equal to the identity. Actually, I don't like the way that's written. Let me scratch that out and say this. A inverse times A is equal to I, and A times A inverse. My handwriting's horrible. Bear with me, guys. A inverse times A is going to be equal to the identity, or I could do matrix A times its inverse. That would be equal to the identity. So if I can find a matrix A minus 1 such that when I multiply it times A, I get the identity, then A minus 1 is called the inverse of A. Let's look at the two matrices I have here. A and B. What I want to do here is just to show you that I have two matrices, and it just so happens when I multiply matrix A times matrix B, I get the identity matrix. Multiply B times A, I get the identity matrix. So if I can find two matrices that I multiply and get the identity, then that tells me that these two guys are inverses of each other. If they multiply to give me I, they're inverses. If they multiply to give me I, they're inverses of each other. Well, our goal is to actually find an inverse, and we'll look at it two ways. We'll look at a 2 by 2 matrix, then we'll look at higher order matrices and see how to find the inverses of those. So I'm looking at just a generic 2 by 2 matrix we're going to call A, B, C, D. Then a quick little scheme to find the inverse is to find the fraction 1 over AD, that cross product, minus this cross product BC. Then we take the matrix and we configure it, the new matrix for the inverse, by switching out D and A and taking the opposite of B and C. This little scheme will find the inverse of any 2 by 2 matrix. A, B, C, D, any 2 by 2 matrix. We find the cross products, AD minus BC. Put that at the bottom in a subtraction format. Switch A and D, opposite of B and C. Let's use that scheme to find an inverse. So I've got three 2 by 2 matrices. The formula is 1 over AD minus BC times, switch the 4 and the 1, opposite of the 9 and the negative 3. So if we look at the formula on the previous page, I'll have 1 over AD is going to be 4 times 1 minus BC will be 9 times a negative 3. So I've done my cross products, AD minus BC. Then I have to configure my resulting inverse matrix by switching out the 1 and the 4 and taking the opposite of the 9 and the 3. Switch the 1 and 4, opposite of 9, opposite of 3. But let's clean this up. I'll end up with 1 over 4 plus 27 times this matrix, which would be written as 1 over 31 times 4, negative 9, 3, 1. And you can leave it like this, but it would be best to distribute out that fraction into your matrix. So it's kind of running out of room here. If I distribute the 1 over 31, I'll get 4 over 31, negative 9 over 31, 3 over 31, and 1 over 31. That's the inverse of that 2 by 2 matrix. Let's work on the second one. 2, 1, 5, 3. And let's look at 1 over AD minus BC. Here's AD, here's BC. So I'll end up with 1 over 3 times 2, which is 6, minus 5 times 1, which is 5, times the matrix configured where we switch the 3 and the 2 and the opposite of the 1 and the 5. Well, this works out kind of nice because 1 over 6 minus 5 is just 1 over 1, so I don't have that funky fraction left over that I've got to distribute inside. I'm just left with 1 over 1 times this resulting matrix. So the inverse is just that, 3, negative 1, negative 5, 2. Last one, AD minus BC. So I'll have 1 over AD is going to be 4 times negative 2, which is a negative 8, minus BC, which will be a negative 8. So I end up with negative 8 plus 8. and then I have the whole matrix configuration behind it. But stop here, because you'll notice that I end up with a 0 in the denominator. And since the beginning of the semester, or since you've been doing any type of algebra, we know that division by 0 is undefined. So because of this, the inverse does not exist. And the name for that is singular. A matrix is said to be singular when the inverse does not exist. Now we can also find the inverse on our calculator. So instead of relying on doing this by hand, might make a careless mistake, we can find the inverse on our calculator. And I'll just do it, I'll start with this 3 by 3. But you could go back and check these 2 by 2 matrices to see what happens. We need to first input the matrix into our calculator, the same way we did when we talked about putting a matrix in our calculator. But the key that we're going to use to find the inverse is this one. We'll hit the x to the minus 1, and on our display we'll see something like that, and that calculates the inverse. So let's go to our calculator. Let me get the matrix. Up there it is. Okay, let me scoot this over. Here's our matrix that we want to put in. So we go to second matrix, jump over to edit, and you can put this one in any position you want. I'm just going to put it in this position A and call it a 3 by 3 matrix. Typing in the 1, -2, -4, 2. Then we press enter after each number that you type in. Go back and check that you have everything typed in the way it should be. And once everything is typed in, press second and quit. Now I need to get the name of A on my display so I can hit the x minus 1 button so it'll find the inverse. So remember, we go to matrix, stay under names, and pull the matrix up. Now we're going to hit the x to the minus 1. Oops. Come on. There it is. We'll hit the x to the -1 button, which will tell the calculator, hey, find the inverse. Well, it'll do it, but if there are decimals involved, you'll get these probably really long decimals, and you can have the calculator, and I always want you to have the calculator convert those to fractions. So when your inverse or any matrix has decimals, hit the Math FRAC feature, the very first one, and that takes your answer and converts those decimals to fractions. This is a much better format that I would like for the inverse, with fractions rather than decimals. And you can see I have it written right here. Your inverse should look like this, and that's what we got on our calculator. So use that feature to find the inverse of any matrix, whether it's a 2 by 2, you can do it by hand, or but 3 by 3 is definitely on the calculator.